All right, so today we're going on to solving linear inequalities. Yesterday we were just substituting values in to see if the linear inequalities that we had created were true or false. Today we're actually going to solve them. So first off, I want to do a little exploration with you. Let's look at the inequality 3 is less than 8. We know that that is an absolutely true statement. So what I'm going to do is I'm going to do 4 things to 3 is less than 8. We're going to add to both sides, we're going to subtract from both sides, we're going to multiply, and we're going to divide. Because when you're solving inequalities or equations, what you do to one side of the problem, you have to do to the other. So for example, let's say we're going to add to both sides. I'm going to add 2. So now I have the inequality 5 is less than 10. Is that still true? Yes, that's still a true statement. Okay. Now I'm going to subtract from both sides. 1 is less than 6. And that's still a true statement. Okay, now I'm going to multiply by 2. 6 is less than 16. Okay, this is like getting really boring, right? That's still true. And now I'm going to divide by both sides. I'm going to divide by 2. 1.5 is less than 4. So really all we've done is we've shown here that this particular problem holds true for the basic 4 operations with the number 2. I'm going to just lead you on a little bit more. We're going to do 3 is less than 8 again, but this time we are going to use a negative number. What would happen if we added a negative number to both sides? Well, let's add a negative 2. Okay, we still get a true statement. Let's subtract a negative 2 from both sides. That becomes 5 is less than 10. We still have a true statement. But look what happens here. If I multiply by a negative 2 here, we get negative 6 is less than negative 16. And we know that is a false statement. So we've run into a bit of a problem. All right, I'm going to divide by negative 2, divide by negative 2. Negative 1.5 less than negative 4. Ooh, we've got another false statement there. So we have a little exception to the rule that we have to learn when we solve inequalities. When we divide or multiply an inequality by a negative, we must switch the inequality sign. And notice, it was only when we divided or multiplied. Adding and subtracting, it seemed to work out. Now, please write this down if you don't know this. This is huge. Huge, huge, huge from now on in algebra. Algebra 1 and Algebra 2. All right, so let's solve this equation right here. We solve these the same way we would do anything else. I'm going to move from one side to the other. So first thing I'm going to do is I'm going to add 3. Remember, when I add, it was okay. We don't have to change anything when I add. Those cross off. I get 4x equals 8. I'm going to divide by 4 now. But remember, it was only if I divided by a negative that I have to switch the sign. So x is greater than or equal to 2. Put greater than or equal to 2 up there. Greater than or equal to up there. All right. That is an answer. As long as I pick an x value greater than or equal to 2, I will result in truth statements. In this statement being true. Now down here, what we have is a number line. It's another way to express the answer. I use a one-dimensional number line. Because there was one variable in the equation that I solved. If I had two variables, if I had an x and a y, then I would use a two-dimensional graph, which we will get to in the year, but right now, one variable, one number line. And this says that my x value can equal 2. So I come down here to the number 2, I circle it, and I color it in, because when we color in math, that represents truth. Greater than 2. Now what I do is I draw a line in the direction of everything that's greater than 2, and I give it a little color in, and then on the end of my line, I put an arrowhead signifying that I can go on forever and ever. See, anything that is colored in or shaded in represents a possible answer. So in other words, since the number 0 is not shaded in, 0 would not work in this problem. 4 times 0 minus 3 greater than or equal to 5. 0 minus 3 is negative 3. Is that greater than or equal to 5? No. But any number that is shaded in would work. So I can pick 10. I like that. 4 times 10 minus 3. That's 37. Is that greater than or equal to 5? Yes. All right, so what we have are two ways. We have a graphic way to represent our answer, and we have what's called an algebraic way to represent our answer. All right, I'm going to solve this one. I'm going to minus the 8 first. That cancels out. It's greater than 8. Okay, so now I'm going to divide by a negative 2. But be careful. When you divide by a negative 2, we notice that it makes the signs change. Right? Negative divided by a negative changes to a positive. A positive divided by a negative changes to a negative. And also, our friend in the middle must reverse. Because when we multiply or divide by a negative, we're changing signs. And this is a sign also. So therefore, it must switch, just like this went from positive to negative, and this went from negative to positive. So we have to switch everybody. So what this has told me is that any x value less than negative 4 will make this inequality true. Now, how about if I were to graph that? What would it look like? Come over here, and it tells me negative 4 won't work. So I circle negative 4, because what's the very next number less than negative 4? Most of you are going to say, well, negative 5. But that's not true. How about negative 4.1? That's less than negative 4. And somebody would say, how about negative 4.01? And then you could keep going, negative 4.001. So they're all true. So we signify by using an open circle to say, well, this is our boundary. We can't touch negative 4, but we can touch any number less than negative 4. And that's what it would look like. And once again, if I clean this page up for us a little bit, I can pick a number. Let's pick 0. That's a great number to pick. Is 8 minus 2 times 0 greater than 16? Nope, 8 is not greater than 16. So that's why all these numbers that aren't shaded in don't work. How about if we chose that -4, just to show you what would happen if we chose the -4? 8, -2 times -4 is +8. Is 16 greater than 16? Nope, it equals. And that's why -4 is not shaded in. I'll pick a number less than -4. Again, let's make it easier on ourselves. Let's pick -10. That becomes 8. Negative times negative is plus. So is 28 greater than 16? Absolutely. That's why all these other numbers that are shaded in work.
All right, so it's not that hard. All we have to do is go step by step. So the first thing we're going to do is distribute the 8, because that's what the problem's telling me to do. So I get 8x minus 16. I'm going to keep going. Wait, there's another distribution of a -3. So that's -6x minus 3. And you know what? Before I go on to the other side, I'm going to clean this left side up over here. I got 8x and a -6x. That gets me 2x. Then I have a -16 and a -3, which gets me -19. All right, so now I'm going to keep moving along. Go to the other side. All right, 7x, nothing's happening to him. +4, nothing. Oh, got to distribute this -3. That's -3x minus 3. And the same thing, I'm going to stay over here. I'm going to clean this up. So 7x's take away 3x's are 4x's. And then 4 minus 3 gives me a +1. Now, I'm going to do something a little different here. Because I don't like negatives in front of my variables, I'm going to move this 2x over to the right side. When I move it over to the right side, remember, it comes over, changes its sign, so now I have positive 2x. And then I'm going to take this 1, move it to the other side. Its operation gets inversed, so it becomes a minus, and I get -20. So now when I go to divide, my variable didn't have a negative coefficient, so I don't have to worry about dividing through by a negative and flipping the inequality sign. Now some of you don't like to read an inequality this way. I can rewrite it x first, but careful, greater than or equal to -10. And you're kind of like, well, you ended up flipping the inequality. Well, I ended up flipping the entire inequality equation, so to speak, right? If I do this, I can flip left, right, and look, I get the same thing. X is greater than or equal to -10. Isn't that right, Mrs. Sullivan?
Yes.